projects. In this video, we are going to discuss about the project which is lymphocyte detection method based on improved YOLOv5. So let's understand what is the project about. So what are these lymphocytes? Lymphocytes, they are the type of white blood cells which are essential for our immune system's function. So what do these lymphocytes do? They fight off infections and diseases. It means that these lymphocytes, they prevent us from infections and diseases. So variations in these lymphocyte levels, they can indicate different health conditions such as autoimmune disorders, infections, and cancers. So in the case of cancer, the number of lymphocytes present in tumor tissues can predict how the disease will progress and how well treatments might work. But here the thing is, figuring out what's happening with these tiny warriors in tissues is not an easy task. So, detecting lymphocytes is crucial for diagnosing diseases, providing prognostic information, and guiding treatment decisions, especially in conditions like cancer, where lymphocyte density correlates with patient outcomes. So, identifying lymphocytes manually in pathological images. So, identifying lymphocytes in pathological images can be time consuming and also they are prone to errors. So to address these challenges, the author in the base paper, he has proposed the model called YOLOv5. So he has proposed a model called YOLOv5. He in the project he has built several models such as YOLOv3, YOLOv6N, YOLOv7 Tiny, YOLOv7, V5S, MSS, YOLOv5 Transformer, YOLOv5X6, YOLOv8N and YOLOv8S and RetinaNet. So he compared all the models and chose the best performing YOLOv5 model. But we built all the models in our project, which are built in the base paper. So we built all these models. And then when we compared, we found that YOLO V8S has performed well. So it achieved highest MAP score. So we used it for deployment in the project. So moving on as an extension, we have used Flask framework with SQLite, which is integrated with SQLite for deploying the project in the web application. So how did we implement it? First, we explored the data set, which involves reading and plotting images. Then we move on to image processing tasks like converting images to blob objects, defining classes, and specifying bounding boxes. After that, we loaded pre-trained models and proceeded with the annotations, resizing, and data augmentation. And then we built various models and evaluated them using mean average precision, and recall, and selected the best performing model and deployed it in the front end. So moving on to the front end integration, we have integrated Flask for deploying the project. So Flask is the front end to our project. Flask is a lightweight web framework for creating websites using Python. We use it in the project to make a website where people can interact with the lymphocyte detection system. With Flask, we can set up features like sign up and sign in using simple database called SQLite 3. So users can upload images on the website for analysis. Flask helps us to manage all these interactions by directing them to right parts of our project, where images are processed and predictions are made. So in this way, users can easily use the project using a web browser thanks to the Flask, making everything work smoothly together. So moving on to the software and hardware requirements. To implement this project, we need software and hardware requirements. So in software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And the hardware requirements which are needed are operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So moving on to the algorithms used, these are the algorithms which are built in the base paper. So we also have built the same models for lymphocyte detection. So among all the models built, we observed that YOLOv8S has performed well, so we chose it for deployment. So let's understand first what is YOLO. YOLO it stands for You Only Look Once, and it is a state-of-the-art object detection algorithm that processes images in real time. And it provides a fast and efficient method for identifying objects within them. It operates by dividing the input image into a grid and predicts bounding boxes and class probabilities for each grid. Unlike traditional object detection methods that require multiple passes over an image, YOLO performs detection in just single pass, directly predicting bounding boxes and class probabilities for multiple objects simultaneously. So this approach makes YOLO particularly well suited for applications requiring real-time processing. So what is this YOLO V8 is? It offers higher accuracy and speed with advancements like mosaic data augmentation and anchor-free detection. It comes in different sizes to cater to different application needs and computing resources. So this is the improved version of the YOLO. So let's execute the project. To execute it, first we have to open the code folder which contains source code files. So these are the source code files in the code folder of the project. So let's understand each file, how will they be used in the project before execution. So first, let's see the dataset folders. So we have dataset in YOLO V5, V6, V7 and V8 folders. In YOLO V5, we have two more subfolders. One is train and the other one is valid. In train, we have two more subfolders. One is images and the other one is labels. In images, we have all the lymphocyte tissue images. So we will be using all of these images to train the YOLO V5 model. So here we can observe that there are 1626 images. So we'll be using all of these images to train YOLO V5 model. Here in the label folder, we have files containing annotations or the labels for objects in corresponding images. So each label file, it corresponds to an image file in the image folder. For example, this file corresponds to this image and this file corresponds to this image, which provides details about object locations and classes within the image. Get back. Here in the YOLO folder, sorry, labels folder, all these label files, they follow the YOLO format. I'll show you a sample. I'm opening a file here. Here, each line represents a detected object. So here, each line represents a detected object. As there are 4 lines, 4 objects are detected in the image. In each line, we have object class index followed by its bounding box coordinates, which are normalized to image dimensions. So in the bounding box coordinates, we have x limit, y limit, width, and height. So similarly, we will have in other label files also. So now close this, get back to YOLO V5. In valid also, we have two subfolders. One is images and labels. We use train folder to train the models and valid folder to validate all the models which are built. Similarly, we have in YOLO V6, V7 and V8. All these 4 folders, they contain the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotation for training and testing the models effectively. Having separate folders, they help in keeping the dataset organized and ensures that each YOLO version receives the correct annotations it needs to function properly. So here we can see there are 2 folders, images and labels. Similarly in YOLO V7 also and YOLO V8. Here in sample folder, we have the images. So we'll be using all of these images as test cases in the front end to detect lymphocyte tissues. So get back. Here we have the static folder. This folder contains files related to project styling and interactivity. They include CSS, JavaScript, and Bootstrap files. These resources are crucial for enhancing the visual appeal and functionality of the project's web interface. So moving on, here we have templates folder. Here lies all the HTML pages utilized in the project. They are index.html and about.html. Each HTML file represents a different page of the website, which provides the structure and the layout for displaying content to the users. And moving on to the app.py file, this Python file encompasses front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. So this is the model file which contains the algorithm information, and this will be loaded into the project code during runtime. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. And the last file is model file. So we will execute the project. So we need to copy the path of the code folder from the address bar of the file explorer. So copy the path. Now open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folder's path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and it will perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is localhost and port. So this is the localhost and this is the port. Now copy this local link provided by Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste the link there. Paste the link and then click on enter. So this is the web page of the project, which is displayed in the browser, and this web page is built using Flask framework. So first we need to sign up. So click on sign up and enter all the registration details if we are registering newly. I already registered and I have an account in it, so I'll directly sign in. So click on sign in, enter username and the password, and click on login. We have logged in successfully and we are redirected to detection page. So here we can see a choose file button. We need to click on that for uploading the images. So click on choose file. So these are the lymphocyte pathological images. So I'm going to upload the first image. Click on open. So image has been loaded. Soon we'll get the detection. So here we got the detection. We can observe that there are 2 lymphocyte cells are detected and a green color bounding box is drawn around that. And it has labeled it as lymphocyte. So here we can observe that it has detected. So now click on detection for uploading some more images. Click on choose file. So now we'll be uploading fourth image. Click on open. Here we will get the detection now. So we can observe that there are 2 lymphocyte tissues are detected. So here we can observe there are 2 are detected. Let's upload some more. Click on detection. Click on choose file. So now we will be uploading this image. Image is loaded. Now we will get the detection. So here we can observe there are 5 detected. That are 5 lymphocytes are detected. So here we can observe that there are 5 lymphocytes are detected. Let's upload some more images. Click on choose file. So we'll upload this image. Image is loaded. Soon we'll get the detection. So here we got the detection. So there are 4 lymphocytes detected. 1, 2, 3, and fourth one is here. Let's upload some more images. So I'm going to upload this image. So here we can observe 3 are detected, 1, 2, and 3 lymphocytes. We'll upload one more image. Click on choose file. So now we will be uploading this image. Image is loaded. We'll get the detection. So here we can observe there are 3 lymphocyte tissues detected, 1, 2, and the other one is 3. So now get back. Click on detection. Click on choose file. So now we'll be uploading this image. We'll get the detection soon. So here we got the detection. 3 lymphocytes are detected, 1, 2, and the other one is 3. Click on detection. Click on choose file. So now we'll be uploading this image. So here we got the detection. 1, 2, 3. 3 lymphocytes are detected. So let's upload some more images. Click on choose file. I'll upload this image. So here we can observe 3 lymphocytes are detected, 1, 2, and 3. Upload this image. So here we can observe 3 lymphocytes are detected. So wherever there is purple color tissue, we can observe that lymphocyte is being detected. Now we will see the graphs of the project. So click on graph. So here we have precision recall curve graph of YOLOv5. Here on x-axis we have recall score and on y-axis we have precision score. And this is F1 score graph of YOLOv5M model. And here we have confusion matrix of YOLOv5. This is precision score comparison graph. Here on x-axis we have precision score of each model and on y-axis we have all the algorithm names. Here we have recall comparison graph and here we have MAP comparison graphs. So now click on sign out. In this page, just by uploading images to the system, it will detect lymphocytes. So our project has been successfully built an automated lymphocyte detection system featuring advanced algorithms and a user-friendly interface. With the integration of Flask framework and robust user authentication, clinicians can effectively employ AI-powered tool enhancing disease detection and management for better patient outcomes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.